This video introduces half-angle formulas and uses them. This is probably the formula I use the most when trying to evaluate a trig function for an angle that's not actually on the unit circle. So you'll notice that we have three different formulas for tangent. I typically use the one that doesn't have a radical. Why not? Make my life easier. Please note that the plus or minus symbol for each formula does not mean there are two possible values for each function. Instead, it indicates that you must determine the sign of the trig function, either positive or negative, based on the quadrant in which the half angle lies. So let's find the exact value for sine of 7 pi over 12. Anytime the denominator is 12, I know that I'll be able to find it on the unit circle because 12 is half of 6, so this is the same as sine of 7 pi over 6 divided by 2. So 7 pi over 6 is going to be our theta. So we look up here to our sine formula. This is going to be plus or minus the square root of 1 minus cosine of 7 pi over 6, all that divided by 2. So let's think about whether we're going to want the plus or the minus. Think about what quadrant 7 pi over 12 would be in. 6 pi over 12 is pi over 2, so 7 pi over 12 pushes us just into the second quadrant. And sine is positive in the second quadrant, so we'll lose the negative and just keep the positive. All right, so now we need to plug in our value of cosine of 7 pi over 6. Of course, I would make a triangle to get that value. 7 pi over 6 is pi over 6 into the third quadrant. So there's our 30-degree reference angle. So that gives us negative square root of 3 over 2 for cosine. I'll clean this up a little bit in the numerator. 1 plus square root of 3 over 2 all over 2. And then we want to simplify the complex fraction inside the radical. We'll do that by multiplying everybody by 2. That gives us the square root of 2 plus the square root of 3 over 4. And then we'll use our quotient rule for radicals and break this up into the square root of the numerator over the square root of the denominator. We get a final answer of square root of 2 plus square root of 3 all over 2. Next, let's find the exact value for cosine of 22.5 degrees. 22.5 is half of 45. This is cosine of 45 degrees divided by 2. So that means 45 degrees is going to be our theta. So you want to look back to our formulas. Our cosine half angle formula is plus or minus the square root of 1 plus cosine of theta all over 2. We need to decide whether we're going to use the plus or the minus. So let's look at which quadrant cosine of 22.5 degrees would be in. Well, that's right here in quadrant 1, and we know cosine is positive in quadrant 1. So we just want the plus again. And let's simplify. Cosine of 45 degrees, square root of 2 over 2. We want to simplify the complex fraction. We'll do that by multiplying everybody by 2. We get the square root of 2 plus the square root of 2 all over 4. And just like in the last example, we want to break it up into the square root of the numerator and the square root of the denominator. Since our denominators are perfect, we get the square root of 2 plus the square root of 2 all over 2. Lastly, we have a tangent. Anytime our denominator is 8, when we're in radian like this, we also know that we're going to be able to use a half angle formula because 8 is half of 4. So we'll turn this into tangent of 3 pi over 4 divided by 2. So this 3 pi over 4 is our theta. Remember that tangent has 3 different formulas. I'm going to choose one of the ones that does not have the square root in it. I'm going to use 1 minus cosine of theta over sine of theta. That'll be 1 minus cosine of 3 pi over 4 over sine of 3 pi over 4. Since this formula doesn't have a plus or minus, we don't have to worry about deciding what the sign of tangent is in that quadrant and determining the plus or minus from there. We should get a positive answer because 3 pi over 8 is in quadrant 1 and tangent's positive in quadrant 1. Let's plug in and simplify. Cosine of 3 pi over 4, that's negative square root of 2 over 2. And then sine of 3 pi over 4 is a positive square root of 2 over 2. Cleaning up our numerator a little bit, 1 plus square root of 2 over 2 over square root of 2 over 2. And we want to simplify the complex fraction by multiplying everybody by our LCD of 2. We're going to get 2 plus the square root of 2 all over 2. Now this one I'd probably rationalize just because it's going to be easy to rationalize. So it's going to give us 2 square root of 2 plus 2 all over 2, which we can break up into 2 separate fractions and simplify to give us a final answer of square root of 2 plus 1.